I'm going to focus very much on the question of, can we make wood better? Of course we can, in many different ways. Holger talked about chemical modification, and for me, because my vice, as it were, has been wood-based composites nearly all of my life. Right from the beginning, when I started my university career, we were the wood scientists. The wood scientists were a small group amongst a huge number of foresters, and it's very often the case around the world. The forestry department is much bigger than the wood science. Forestry seems to have a much easier reputation for being environmentally friendly. Us wood scientists, we're seen as the dirty people because we cut trees down and we have factories and we make a mess. But in actual fact, as everybody has been saying, unless you use the wood, you're not having an impact on the climate. So right from that beginning, I decided the wood scientists had a greater impact on the environment than foresters. And I've been fighting that battle ever since, because it's not cutting the tree down that's a problem. It's not replanting, which is the problem. If we were concerned about cutting plants, none of us would eat bread, because every year the whole field is cut. But that's not a problem, because next year they plant it back again, and it's the same for forestry. So why am I fascinated in composites? Besides the reason I've just given you, one of the things is I like the fact that we can take rubbish material like this and we can convert it into particle board products. Now, particle board isn't the most beautiful, I agree. You're not, most of the time you don't see it because we cover it, because it's so ugly, we cover it with different finishes. But there isn't any one of you that can't see some particle board somewhere. Probably look around you, there's some furniture, or the floor you're standing on is probably made from that stuff. And in Europe today, a typical particle board is 40% recovered wood. And there are a number of factories that use 100% recovered wood around Europe. So there is a real future of recycling more wood into useful products like this. I'm also like the idea of being able to take a tree, cut very, very thin pieces of veneer from it, very valuable, very high performance products. So here we see laminated veneer lumber. So it's not a plywood. This is where basically all the veneers are running in the same direction. But this allows us to make very long pieces of wood, very wide pieces of wood, very deep pieces of wood, which are very high performance, with a known performance as well. One of the beauties of wood is its variability, but that's also one of the technical constraints in using it. We can't just take any piece of wood and use it in building. Low density ones are not as strong as high density ones, and it gets very confusing for those who don't really know about wood. And I also like the idea of taking very low quality wood, trees, of all different kinds. So Georges mentioned some earlier. So this is a photograph. It's quite an old photograph now, over 10 years old. This is the result of Tempest Klaus, which hit the southwest of France over 10 years ago. And the real problem was it cut a lot of the trees in half. So the wood was you couldn't use it for sawmilling. If the tree falls from the root, you've got a chance. But here, a lot of them snapped in the middle. But what we can do is we can take wood like that, we can break it down into its smaller components, we can defibrate it, make it, cut it into individual fibers or small pieces of wood, and that allows us to make very, very uniform products. So I'm sure you know medium density fiberboard. This is the product before it is hot pressed. That mattress is entirely uniform. Same moisture content, same color, same density throughout. When we press it, however, it's going to have a range of different properties. And it is a very high performance product. And one of the main successes for this product is because we can machine it in very fine detail. I know we can do the same with solid wood, but the problem with solid wood is it has knots. The grain isn't always in the same direction, so the wood deviates. And the tendency in modern technology is to move to automated machinery. very clever machinery, but also very stupid. So if the sensors detect that the piece of wood is not straight or something, it stops. With MDF, you buy the plaque, it's largely the same density, the same thickness, the same properties. And so you can run these dark factories, these lights out factories where there's nobody present and this material just goes through the process. And MDF has, within my career, gone from basically an unknown product to the second most produced panel product in the world, 100 million cubic meters around the world. And this is why it's proving to be a real nuisance in the recycling world. So this is a slide I use with my students. Wood is an excellent material for construction. It's strong in tension, it's lightweight. I can use a saw, I can drill it, I can shape it. Unfortunately, it does shrink and swell. Insects do eat it, it can burn. Concrete, on the other hand, it's got the opposite properties. It's not very strong in tension. That's why we have to put steel reinforcement. It's very heavy. And although we can make different shapes, we have to think about those shapes before we do anything. We have to make a mold to get the shape. If we make a mistake, it's quite difficult to correct it. On the plus side, it's very durable, it's pretty fire resistant, it's quite moisture resistant, and it's very strong in compression. So if we combine these two materials together, you can get the best of both worlds. So this is an example of cement bonded particle board, which has been made around the world in relatively small quantities for over 30 years, but still very few people know about it. It's a particle board bonded with cement. You can drill it, you can sand it, you can cut it in the same way, but it's fire resistant, very stable. And as someone once said, this is a solution looking for a problem. So using different composite technologies, we can make wood longer, wider, thicker. We can make it stronger by densifying it and impregnating it. So Alexander, isn't he, working on that? We can make the materials dimensionally stable, like I just showed you with cement bonded particle board. Cement bonded is also bioresistant, it's fire resistant. We can make it smoother, we can make it very direct decorative. We can change wood almost how we want. However, all of the things I've just talked about are technical performance things, and that's what we've tended to focus on. And it's only in the recent years, as we become more and more aware of our impact on the environment, that we now realize we can't just think about technical performance. We have to think of the whole cycle. Particle board is quite good because we use a lot of recycled material, so it's already in that cycle. But the honest factor is that manufacturers didn't do it for ecological reasons, they did it for financial reasons. Recovered wood has a typical moisture content of 25%. Wet wood, particularly softwoods, can have 100% moisture content, and you have to dry the wood. So this is why using recovered wood is much cheaper, because you're not using all that energy to dry the wood. So that's the real reason why recovered wood is being used, but it turns out to be a real benefit for the environment anyway. What your generation is going to have to look at much more than what we did is looking towards the future and thinking outside the box. As several people have said, we've got to think of how can we do things differently? How can we reduce? When this is something that Rupert's mentioned a couple of times. And there's a lot of research in the composites area, which is how to make panel products lighter but with the same performance. And then recycling and reusing materials. We have a very good example in France. It's called an Ecole organization set up by the French government with an eco tax, and they are reusing old furniture and making new furniture with it. That's part of what they're doing. So this whole factor you now need to consider. If you're going to develop a new product, it's no longer acceptable just to think about the technical performance and the economic. You now have to consider the environmental impact, the whole thing. So think of that in your future.